All right. So, yesterday we left off here. We were talking about global circulation. One of the things I do actually want to do is go back and remind you that these are the questions we're answering. We're talking about what factors influence climate, and you really need to be able to answer this question. Obviously, there's an answer right there, right? Incoming solar radiation or energy, but what does that mean? Earth's rotation, well, how does that work? Global patterns of air and water circulation. What are global patterns of air circulation? And then the particular gases that are in the atmosphere, how do those affect climate? And Earth's surface features, or what is topography, how does that affect climate? So remember that you need an explanation for each of these. So we've been reading through these notes very carefully, and you are still expected to be marking your text, which are your notes, right? Using highlighters, adding on, making places like giving yourself examples. So always, like, you can have the explanation. You should probably put it in your words if it's something that's complicated, and you should add examples to that so that your notes become a tool for you to learn this material. I want you to take a look at what we were talking about yesterday, right? So global air circulation. So what we've got is this really big idea about the way air moves, and I explained to you really carefully how water moves, like where it evaporates, how it rises, and then how it falls out, and how that air dries. And as that precipitation is dropped off, that dry air moves, and it cools, and then it falls back down, and then it warms as it goes across the continent or across the ocean. And that is being that water is now warming and picking up moisture as it moves along that warm region, so that we get these large cells. I do actually want to show you a different illustration. It's pretty awesome. Okay, so here what we have is my favorite illustration, just because it helped me to see it three-dimensionally, like what's going on the earth. So all those like bloop, 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 big white, blue-ish things represent the atmosphere, and the convection cells that kind of create these regions of motion on the earth. And you can see they're not even. The reason they're not even has to do with heating, but it also has to do with the rotation of the earth. And the Hadley cell is the first one. I think let's see, we've got it doesn't say. I think each one is actually named. So Hadley cell, I know that the polar cells are up at the top, and then I can't remember which one, but they create cells. So the Hadley cells are those big, they call them cells, but it's almost like a band of air mass that is rotating, but also wrapped around the earth because of those regions of heating. And you can see, so the heating here. Let me see if I can get this. The heating here, right? I just pick a different color. There we go. And this area causes the, so that's at the equator, and that's what causes the evaporation, as I was talking about before. Then the air cools, and as it cools, it's dropping, it's getting rid of all of that precipitation pretty quickly, and then it drops down and warms again near this on these surfaces and moves over here. And as it's warming, it's picking up not precipitation, it's picking up water vapor, and then as it rises, it condenses again. So this is a pattern, it's ongoing, and that is a global pattern. So remember that we're actually really talking about like how climate is created. One of the most important aspects of creating climate on the earth that can support life is the presence of greenhouse gases. Solar energy flows into the earth. Some is reflected back into space. Some is reflected off of clouds, but some of it will actually be absorbed by greenhouse gases and will warm the lower atmosphere. And it is the presence of those greenhouse gases and the capacity, so like CO2, water vapor, nitrous oxide, methane, that there's some trapping of heat that happens. And water vapor will warm directly, whereas some of the other gases will trap the heat so that it can't escape. And here's how this works. So light is a lot of different wavelengths. We see a very small window called visible light. But on either side of that, there's ultraviolet, which is shortwave radiation, and can be very, very damaging. And the atmosphere will actually, it protects us from that damage. But on the other side is infrared. And when light comes in and it hits materials and it's absorbed by those materials are able to take on a certain amount of that energy before they start giving back out some of that energy, like they get full of energy. It's called specific heat. Water has a specific heat, rocks have specific heat, iron has specific heat, and so they'll take on quite a bit of energy. Now, water is pretty high. It will take on quite a bit of energy before it starts re-radiating that heat, but it'll re-radiate that warmth. When land does this and it takes on heat and then it starts to re-radiate the heat, anytime materials re-radiate it, it doesn't radiate it at the same wavelength. It actually radiates that energy mostly as infrared. And infrared is what we feel as heat, as warmth. So it does that radiation comes in, it absorbs, it re-radiates, but then the infrared doesn't have the same amount of energy and it isn't able to escape. So it'll kind of bounce around in the atmosphere for a bit. Because of that extra energy, it holds that heat in. The atmosphere actually is like a blanket that kind of insulates the whole globe. And one of the most effective greenhouse gases for that contains carbon, CO2. Another one that contains carbon is actually CH4, which is methane. So the carbon containing molecules they do a really good job of holding the heat in, maybe because of the absorption and re-radiation. I would have to look into the physics of that one a little bit further, but they're really good at it. And that's great for us. But if we put too many of them into the atmosphere gets too warm. And we're talking about at the surface of the atmosphere. And we're talking also about average temperatures. So some places are colder, some places are warm, but overall average, the Earth has been holding on to a little more energy than it needs to because of human activities. And that is the production and burning of fossil fuels, clearing of crops. Because of that warming, we start to see some of the areas that should be frozen are starting to thaw. And so we see the effects of emitting greenhouse gases into the atmosphere. It can actually do some change within the climate. We look at the Industrial Revolution as kind of a marker for when human activity started to increase, like substantially increase the presence or the amount of CO2 that was in the atmosphere. And we see that we are able to affect climate, and we see that climate is shifting and changing a little bit. So greenhouse gases, I know you might hear about that in relation to, global warming and climate change in a very negative light. However, it is the presence of those greenhouse gases that establishes our climate in the first place. And so it is necessary. And then another thing that affects climate is Earth's surface features. So this can be from as big as just like Earth's, curvature and the mountains that create some of those global wind patterns. But then we can look at on a more individual scale how biomes are distributed a little bit more they're more uneven, and it has to do with the lay of the land, the way that the land actually looks. So mountains can interrupt the flow of winds. They can affect where storms go. And I'm going to explain this, what the rain shadow effect is. But then even on a smaller scale, some of our human interactions can create microclimates that can mimic things like mountains or deserts or big rock areas. So cities can create microclimates because the brick, concrete, asphalt, which are much like rock, right? They absorb heat and then they'll re-radiate it. So you get like a little heat island, something that'll be really, really warm when it's the summertime. Buildings can block wind flow and can actually affect how much water is making it, onto the other side of a city. Motor vehicles, or heating and cooling systems and buildings will release heat and pollutants, and those can contribute to haze and smog, which can, in a microclimate way, create a little bit more heat because they'll do some trapping of heat when there's more of those particulate matter, more of the particulate matter or more of those particular gases in that region. And so climate, you usually think of it as being really big, but we talk about microclimates too. And so you'll see a lot of the features that we've talked about are mirrored in that. Let me explain rain shadow really quick before we go back over kind of the big idea. So this picture right here, you have a spot in your notes to explain how this works. Now, we see an example of this in California. We have like two mountain sets compared to this one. California is like a bowl, like that. Where we live is in the valley, in the bottom of that bowl, kind of in the middle actually, and we're surrounded by mountains on all sides. But there's an opening to that, and that is in the delta, like the San Francisco Bay. That ocean winds can come in, and they're warm, or they bring with them. Warm, rainy water, and or they'll bring cold, water heavy winds, and they will hit the mountains. Like once the winds come and they hit the mountains, and that moisture can roll over, and it kind of stays. Like water vapor is heavier, it's more dense, it will stay toward the bottom, it'll stay closer to the surface. And sometimes the water vapor in the form of clouds and what would be precipitation doesn't make it all the way up over the mountains. So on the windward side of the mountains, and in our case that's the westward side, the air will rise, it'll cool, and it will release all the moisture, and it'll drop it off there, kind of in a similar pattern to what we talked about with the global wind patterns. So you have this air that, as it rises, it cools off, condenses, clouds form, it all drops off right on that one side, the windward side. And then on the leeward side of the mountain range, air will descend, but it will warm, and it will release what little moisture it has, but it doesn't really have as much because it dropped it all off on the other side. And so you get like a desert that forms. So Reno is a desert, and our region, though semi-arid, has a lot more rain. And so we get more snow in the Sierra Nevadas on the western side. And you see this pattern arise in other places that have a similar setup. So like in India, you have the Himalayas, and those cause a rain shadow for Tibet. Whereas on the India side of the Himalayas, rain will fall often. And that's a north-south thing. So it doesn't have to do with east-west, north-south necessarily, but it does have to do with the features of the land. And the rain shadow is a phenomenon that we want you to understand can create climates on a small scale, and even on larger scales. Like Tibet is huge, right? And India is huge, but there's the Himalayas are huge. But then it can happen on small scales as well, where you see more moisture falling on one side, the windward side of the mountains, and where the wind is actually, coming from and carrying moisture. So what I want to go back and take a look at is if we actually answer these questions. Did we cover all the factors that influence climate? Can you create study questions for each section that help you to really understand these different factors? So incoming solar energy, why does that and how does that influence climate? Earth's rotation, how does that influence climate? Are you able to describe the Coriolis effect? Do you understand it? Global patterns of air and water circulation. So when I look at that diagram, here, let me see if I can grab that diagram. Are you able to describe why this creates particular regions of vegetation versus arid deserts, and why it works that way? And are you able to talk about the gases in the atmosphere and how overall the gases work to trap heat? And then how we see the Earth's surface features, like the land itself and the mountains, how does that affect overall climate? So I want you to connect those ideas, make sure that you create questions in the left-hand column, and that you create a summary for each of those 3 pages, and then you're turning that in. All right. Have a good one. You have a few more items to take care of in Google Classroom. Be awesome. I know it's a short day. It's Thursday. It's almost Friday. We've done a lot of great learning this week. Next week is finals. And so I want to make sure that we get through all of this good information. We got some studying to do next week, and you are going to be finishing up your project. You're going to spend a lot of time working on your project tomorrow. All right. Have a good one. Bye.